NVIDIA's March 2026 hardware roadmap established a definitive transition in the industry. The focus moved from foundational pre-training to agentic inference. Agentic inference employs autonomous systems that execute multi-step problem-solving loops. These agents manage real-time tool use, execute their own code, and operate continuously within enterprise networks without human intervention. Routing sensitive industrial or clinical data through public, cloud-based APIs creates an unacceptable security risk. When proprietary information travels to external servers, it is exposed to latency and privacy vulnerabilities. Granting an autonomous agent access to internal corporate file systems increases the risk service. A compromised or hallucinating model could traverse the corporate infrastructure to exfiltrate data or execute destructive commands. Securing these workloads requires a pivot to hyper-localized execution, keeping inference entirely on-premises. Data sovereignty is the absolute foundational prerequisite for deploying autonomous industrial workforces. The Sovereign Agentic Workbench, or SAW, provides the structural solution. It is a managed infrastructure platform physically localized entirely on owned hardware. Processing data on local silicon enables zero marginal cost inference. Enterprises can run highly sensitive medical records or engineering blueprints through complex models without public cloud exposure or recurring API fees. Apex Forge LLC is the venture operationalizing this sovereign architecture. It is driven by the Apex concept, which focuses on autonomous pivot ecosystems. The underlying Forge engine merges 45 years of clinical nursing and industrial manufacturing experience with edge computing to identify and solve specific industrial latencies. Apex Forge does not build consumer software. It engineers 24/7 physical AI workforces. Combining real-world operational logic with sovereign local compute creates a commercial moat against competitors reliant on cloud-based frontier models. Running sophisticated foundation models on the edge requires a specific physical baseline. The primary inference engine is the NVIDIA DGX Spark, powered by the Grace Blackwell superchip. This node delivers 1 pflop of FP4 performance. This system utilizes 128 gigabytes of unified memory. This allows the CPU and GPU to share resources seamlessly, providing the memory capacity needed for continuous agentic problem-solving loops. The DGX Spark is supported by auxiliary orchestration nodes, the Acer Predator Helios 18 and the Acer RTX 5090 desktop array. These Acer nodes manage high-speed vector databases. These databases use 96 gigabytes of RAM to enable instantaneous in-memory retrieval of corporate knowledge bases. Prolonged inference workloads create heat that throttles tensor core frequencies. Industrial-grade turbofans are required to maintain maximum computational speeds during continuous agentic responses. Because agentic workflows hold critical variables in volatile memory, the system uses lithium iron phosphate backup power. This protects the clusters from micro-outages that could wipe the key value caches. This hybrid fusion of workstation silicon and flagship consumer GPUs creates a rapidly deployable AI factory. To transition this hardware into a secure enterprise node, the system utilizes the NemoClaw software stack. Internal model guardrails are susceptible to prompt injection. For absolute security, the system employs NVIDIA OpenShell, a runtime governance layer between the agent and the hardware. OpenShell enforces a deny-by-default access protocol. Every network call or file operation requires explicit approval from an infrastructure layer policy engine. Agents are confined to isolated computing sandboxes using kernel-level isolation. This prevents cross-contamination, ensuring that a hallucinating model cannot affect the host system or parallel agent environments. OpenShell provides the foundational session isolation necessary to grant AI agents autonomy within a regulated enterprise network. As the complexity of automated workflows grows, the edge architecture must scale into regional multi-tenant operations. This shift involves the Vera Rubin NVL72, which moves away from discrete server parts toward holistic rack-scale supercomputing. This data indicates that the Vera Rubin NVL72 reduces relative token generation costs to 1/10 of the Grace Blackwell generation. The shift is driven by the performance gain shown on the left, a tenfold increase in inference throughput per watt. The NVL72 unifies 72 Rubin GPUs and 36 Vera CPUs into a single NVLink copper spine, functioning programmatically as one coherent processor. This rack-scale design redefines data center economics, making the generation of millions of reasoning tokens financially viable for industrial fleets. Traditional x86 CPUs become a bottleneck when orchestrating the multi-step reasoning and tool use required by AI agents. To solve this, the Vera CPU features custom-designed Olympus cores. These are engineered specifically for agentic reinforcement learning workloads. These cores employ spatial multithreading, physically partitioning resources to ensure predictable performance under extreme utilization. Managing these cores at scale requires NVIDIA Dynamo 1.0, the operating system for the AI factory. Large-scale inference is often slowed by the inefficient movement of key-value caches across clusters. Dynamo intelligently routes incoming agent requests to the specific GPUs that already hold the relevant short-term memory from previous steps. This memory routing eliminates redundant processing and cuts inference latency across the network. Coupling partitioned Olympus cores with Dynamo's memory routing enables the lightning-fast reasoning required for thousands of concurrent autonomous agents. Global AI expansion is currently limited by the multi-year delays in securing grid interconnections for high-capacity data centers. The DSX Flex software library transforms AI factories into grid-stabilizing assets. Using Emerald AI's platform, the factory aligns compute workloads with real-time grid availability and on-site renewables. It modulates power draw, acting as a shock absorber for the local grid. This power enables the deployment of the Omniverse DSX blueprint to create physically accurate digital twins of industrial sites. Simulating lighting, HVAC, and manufacturing workflows in computer models before physical production begins allows enterprises to achieve up to 20% in energy savings. Apex Forge funds its vision through Boss AF, built on scalable systems. This drives the Black Label Acquisitions Protocol. It uses autonomous agents to scout global supply chains and negotiate net 30 purchasing terms for high-ticket assets like robotic mowers and thermal optics. Because these agents operate 24/7 without human latency, they can process a volume of high-value transactions that generates $270,000 in monthly free cash flow. At this scale, the 5-year wealth trajectory reaches $55.89 million. This entire system runs locally on the sovereign hardware stack, fusing mechanical engineering logic with advanced inference architecture. The sovereign infrastructure is functional. Initiate the protocol. Welcome to Apex Forge.